All right, 6.4, rational exponents. So one of the things we have to recognize is that when we're dealing with a radical expression, we can then transform that into an exponential expression and vice versa. So in this case, the nth root of x is equal to x to the 1 over nth power. All right, and so here you'll see that the square root of 36, when the square root is essentially having, in this case, 2, is equal to 36 to the 1/2 power. The cube root of 64 is equal to 64 to the 1/3 power, and so on. And so we're going to use this information to simplify and do other operations with radicals and exponents. So here it says, what is the simplified form of each expression? So 216 to the 1/3 power. Well, in this case, we know we could change this into the cube root of 216. Keep in mind that 216 is really just 6 to the 3rd power, so that means the cube root of 216 is just 6. Here we've got 7 to the 1/2 power times 7 to the 1/2 power. If we want to, we could think of it this way. We could say 7, or the square root of 7, times the square root of 7. And we remember what happens when we have two items with the same index and we're trying to multiply them. We're going to multiply what's underneath the radical. So this is the square root of 49. And in this case, the square root of 49 is just 7. All right, so in this problem C, we have 5 to the 1/4 power times times 125 to the 1/4 power. So in this case, we really are looking for what is essentially the 4th root of 5 times the 4th root of 125. Knowing that they're the same, we're going to multiply these values together. That's the 4th root of 625. In this case, the 4th root of 625 is just 5, because 5 to the 4th, and then they would cancel. So go ahead and pause the video and see if you can answer the 3 questions here, and then we'll go from there. All right, so in 1, you've got this essentially 64 to the 1/2 power is the square root of 64, so that's just 8. In B, you could take this as the square root of 11 times the square root of 11, or if you want to remember some of your exponent properties, you would just add those two exponents together, and that becomes the square root, 11 to the 2 over 2 power, which is 11 to the 1st. So in both cases, you get 11 as your answer. And then for C, you've got square root of 3, square root of 12, that becomes the square root of 36, which is just 6. So here we're talking about turning exponents into radicals, and then radicals into exponents, and vice versa. So here in this case, that we've seen already, when we have like a to the 1 over nth power, it becomes whatever the end or the bottom denominator is, that is your index, and then in this case, your base goes inside. If you, in this case, have a different fraction, well, let's say that has a numerator and a denominator that are not 1, so let's say 3 over 2. Well, in order to put this into radical form, the 2 is the index, so it's still the square root, but then the 3 accompanies the a underneath. This can also be written like this, where you've got a, and then, oops, I made that way longer than I need to. And then you've got all of this to that power as well. All right, so we're going to look at converting from exponential to radical and then back again. So here we've got x to the 3/7 power and y to the negative 3.5, and we want to write those in radical form. So let's just start with x to the 3 over 7 power. Well, if we remember the previous example, we know that this is going to be the index of our radical, and then we can write it like this. Or we said before, you could do this as well. All right. In the next one, we've got y to the negative 3.5 power. And this problem is going to take a little longer because we have to change this first into a fraction that we can use, so negative 7/2. If you remember any of your exponent rules from earlier on, Algebra 1 particularly, we don't like negative exponents, so in reality this becomes 1 over y to the 7/2 power. So then we convert this over. We've got 1 over the square root of y to the 7th. In this case, since we're square rooting this, we can reduce this again. So 1 over, and this would be y to the 3rd, because we can pull out 6 of those. And then y. And then last but not least, we have to, in this case, rationalize the denominator. So we're going to multiply here to get rid of some things. To rationalize our denominator, we're going to multiply the top and bottom by the square root of y. And so on the top, we get the square root of y. And then on the bottom, these two are just going to result in y. So that'd be y to the 3rd, and a y becomes y to the 4th. All right, this time they're asking us to go from radical to exponential form. So let's start with the first one. We've got the square root of the square root of a to the 5th. And so we know that our index outside here is a 2. So we've got a, it was to the 5th power, and then it was the square root, so we put a 2 there. Then in question 2, we've got the 5th root of b, all of that to the 3rd power. Well, we know this will be our denominator is 5, so we've got b, we've got a 5 on the bottom, and then it's raised to the 3rd power. So it's b to the 3/5 power. Not too bad. Here we have a list of examples of things you learned about exponents in Algebra 1. Maybe you remember them, maybe you don't, but we're going to review most of them here, so hopefully they come back pretty quick. All right, so take a second, pause the video, look through all of the properties you want. We're going to go through a lot of them here in the next few seconds, or next few minutes, so it's not a big deal if you don't look over them right this second. All right, so the first thing they want us to do is to simplify this negative exponent. And we talked about before, we don't want negative exponents in general. You don't want negative exponents when you're dealing with this. So to simplify this, it's going to become 1 over y to the 9/8 power. So we're using this property here. The act of moving it is what's creating or changing the exponent from negative to positive. All right, in the second example, we do something similar, but we only have one quantity with a negative exponent, so it's the only thing that would have to move. So your answer here is going to be y squared over x to the 3rd. So in this case, keep in mind for the first one, we moved this in order to make the exponent positive. So these are what we're looking at. All right, so here we've got a to the mth times a to the nth, which means you're going to add the exponents. Well, for these problems here, we notice they're not in exponential form, so at least for the first one, we need to change them. So this is going to be 3 to the 1/2 power times 3 to the 1/4 power. And so based on this rule, we're going to add the exponents because they have the same base. So this is going to be 3 to the 3/4 power. And what we can do is we can turn this back into a radical form if we want. So we can say the cube root of 3 to the 4th power. Or sorry, that's backwards. My bad. Should be the 4th root. There we go. 4th root of 3 to the 3rd power, which in this case would be the 4th root of 27. In the second problem, very basic problem here, we've got 7 to the 1/2 power, 7 to the 1/3 power. We're going to add those exponents, but in order to add these, we need like denominators. So let's make this 3/6, and we'll make this 2/6. So that becomes 7 to the 5/6 power. We could make this radical form if we want, so the 6th root of 7 to the 5th. I'm not going to multiply this out right now. I'm just going to leave it like that for now. Here we've got a to the mth raised to the nth power means you're going to multiply your exponents. So we're looking at an example where you're multiplying exponents. So here we're going to multiply these two exponents together. So 2/3 times -3, well that's just going to be a -2. The 3's cancel. We don't want negative exponents, so this is going to be 1 over x squared. Here we'll do the same thing. We've got power raised to a power. This becomes x to the, I don't know why I wrote that there, x to the 4th power. Here we've got a quantity inside raised to a power. That power is essentially going to get distributed to all of the items inside, and so you're multiplying it accordingly. It's getting applied to the exponents on those items as well. All right, so let's look at this first example, or the only example here. We've got negative 27, x to the negative 9th, all raised to the 1/3 power. So this is going to go to the negative 9 and the 27. So we've got negative 27 to the 1/3 power. And then we've got x to the negative 3rd power. So here, what we have to think about here for this part is that this is just the cube root of negative 27, which the cube root of negative 27 I know is negative 3. Here I don't want this written like this, so I will change it to 1 over x to the 3rd. And so right now I have negative 3 times 1 over x to the 3rd, which is going to simplify into negative 3 over x to the 3rd. And then we have this problem where we're dividing our exponents. So in this case, they have the same base. So we're going to divide them. So let's change these radicals into exponents so we can go ahead and copy these rules. So this would be x to the 1/3 power over x to the 5/6 power. So our goal here is they have the same base, so we're going to subtract the exponents. So in reality, what we're looking at is x, where we've got 1/3 minus 5/6. Well, 1/3 should probably be changed into 2/6. So 2/6 minus 5/6 means we're going to get x to the negative 3/6. So x to the negative 3 over 6 power is the same thing as x to the negative 1/2 power. We don't want negative exponents, so we're going to have 1 over x to the 1/2 power. We can then convert these back into radical form, so 1 over the square root of x. But like we said before, we don't want radicals in our denominator, so we've got one more set of steps here. 1 over the square root of x means we're going to multiply by the denominator here in order to rationalize our denominator. So in this case, we've got the square root of x over square root of x times square root of x is just x. And here we have one more. When we have a quantity, even a quotient in this case, or division here, raised to a power, you're going to apply that exponent to both of the items inside or multiple items depending on what they are. So in this case, the negative 1/4 is going to get applied to the 3 as well as the negative 1. So let's just see what that looks like. So x to the negative 3 over 4 power, and then this would be x to the 1/4 power. They have the same bases, so we'll go ahead and subtract them. So we're going to get negative 3 over 4 minus 1/4. So go ahead and write this down here. We're going to get x to the negative 4 over 4 power, which is the same thing as x to the negative 1st power. We don't want negative exponents, so this becomes 1 over x.